everyone, I'm the Crunchman, and this is my third update video on YouTube on the CrunchComm project. CrunchComm is one of many low-powered radio communication systems based on the LoRa 915 MHz ISM band. I've had a few glitches along the way, mostly because I'm developing it on an M1 Mac, and not all of the open source community has caught up with the major changes on the M1, but I'm getting there. The second glitch is that I'm paving a new way. I'm doing this using new tools that no one else has used. Now, why they haven't used it could be a very good reason why I haven't been getting very much progress, but to say the least, I have gotten quite a few good progress on everything so far. The tools I'm using are a variety of tools, and I admit I'm not a good programmer. But because I'm not a good programmer, I try to use crutches and tools that any decent person would want to use, such as Figma, which is a graphics creation tool for designing the user interface. It does things like create .css files, as well as Locify, which is a tool that creates graphic native code from the Figma designs and works in conjunction with Figma. And of course, the old standard ChatGPT, a large language model to help me understand code and generate small chunks of code to assist me, as well as analyzing code that I've gotten from other YouTube projects. I'm making really good progress on the CrunchComm project. Once I discovered the existence of a new Bluetooth Python library I had no idea existed. ChatGPT didn't even know about it, but Bart did. So Bard is the one that I've been using mostly now. It won my trust, at least initially. So I have a really good working Python script now that can discover BLE devices on my Mac. I'm also able to advertise my ESP32's device name using Bluetooth. I'll briefly go over the code in just a little bit. The next step is to start writing the code for the CrunchComm app in React Native, which is a cross-platform application platform that can run both on iOS and Android. I was able to come across a video using ESP32 Step Tracker by Taylor Galbraith. I reached out to him, but like all YouTubers, he ignored my LinkedIn messages. But I did spend an entire day going over the code in gory details, and my Xcode knowledge worked because there was a lot of things that I had to work with in Xcode to get it to work properly, like gem, cocoa pads, but it's all starting to be pretty clear, about as clear as mud. So I was able to easily hack up a Python script running on macOS to connect to all of the devices near me. And here is the Python code. This is just a peek of the code. The full code will be put up on my Patreon page, but the module that I did not know about is called Bleak, B-L-E-A-K. I have no idea who picks these names for these modules, but whoever it is, got some really sick sense of humor. But what this code does, it uses asynchronous I/O, which means that a lot of things happening in the background until other things get done. So what this piece of code does is basically scan for the BLE devices and prints them out. So it creates a scanner class and then awaits for the scanner to collect up the devices that it finds, and then it prints them out. And what it comes up with is this right here. You're looking at a list of devices in my home, and one of the devices is right here, my ESP32, which has been broadcasting its identity over the Bluetooth network. This is my iPad. It found that. It found my iPhone, and it found my neighbor's TV set, a Samsung TU7070 TV set. Now maybe I should download an app and hook into that Bluetooth. I'll be able to turn off her TV set after 3 in the morning, which she has it so loud, keeps me awake all the time. Anyway, that's pretty much it as far as Python part of it. Now over on the ESP side, this right here is written on the ESP32. And it has a different Bluetooth module, probably has different names and stuff like that. But what this does, it creates a BLE ESP32 class. It initializes itself and makes sure that it's active, and it lets it know that the Bluetooth is enabled or disabled. And it sets up the IRQ, the link to it, and it just lets it start advertising. And what it advertises, it just simply advertises ESP32 underscore BLE. You see that right up here, right there. The underscore BLE didn't print out, but that's okay. I'm not going to lose any sleep over that. And so it goes through and does advertising data, prints that out, and then it builds up the advertising data in a form that is acceptable to the ESP32. And then it creates the advertising data here. And it does an IRQ here, making sure that everything is required and enabled. Here's the run loop. Just simply loops around one. And this is the start part of it. And this is the BLE part of it working on the ESP32. Okay, now on the Figma side, Figma, F-I-G-M-A, is a website utility that allows you to be able to build very nice graphic user interfaces. And also, it allows you to generate code along with this interface. This is a screenshot. Actually, it's not a screenshot. It's an actual working piece of code, but it's more convenient for me to just present it here. But I actually have it running on my iPhone. At least I have this part of it running on my iPhone. This CrunchComm, and right now it's supposed to just the first part of actually the testing. I'm going to be writing some more React apps along with it, special utilities that are going to let me go in and take a look at the registers of the LoRa transceiver and specifies things like link budget optimizing, as well as doing things like developing the certain registers for doing certain things. In this particular case, I would enter in text. The text would be in a JSON form, because that's what the ESP wants to see is JSON. We're communicating between the iPhone and the ESP32. Again, all of the details on this are going to be available up on my Patreon page. Over on the left, this is actual working React Native code, which runs on React Native and does all of the graphic user interface stuff. And it's just a sample look at it. I've got the whole thing. Again, like I said, you can see all this stuff up on my Patreon. And you have to subscribe in order to become a member. And that would allow you to be able to come in and join the project and become part of it, part of the team that works it all out, you know. Well, that's pretty much that part of it, which was a screenshot of the Locify module for the very first attempt at building the React app. This trial app will essentially be used to give to Andy, our hardware engineer, who will be integrating it into his RF radio module section, while I focus on designing the final GUI, then hopefully getting some more help from Chris for the final app we will deliver with the final hardware. Anyway, I've given you a sneak peek of actual working code already written, but to get the great real deal on everything that we're doing, including the GitHub, the graphic resources, the Figma, and Locify graphics file in the Patreon site. So hop over to patreon.com where I've written an update and subscribe today. The link will be in the description, which is patreon.com/JDCrunchTime. So in conclusion, thanks for watching and keeping up with these occasional updates on the CrunchComm project. And press the thumbs up icon so that YouTube can expose this video to more people. And I'll be posting another update video soon. See ya.